Okay, for what we have regarding functions and for what we have in the definition of functions, we have that a function is a relation where in the xy coordinate system, we're going to have that for each x value, there will be only one corresponding y value. Okay, so for each x value, there is one and only one corresponding y value. And now there are different ways upon which we can express functions. A common introductory way in presenting functions is through sets of ordered pairs. And we have a case here. Okay, we have a set of 3 points or 3 ordered pairs. And we have -1, 4, 2, 9, and 3, 17. And if you notice, we have with our x values, we have -1, which is paired up only with 4. 2, which is paired up only with 9, and 3, which is paired up only with 17. So we do have the condition for a function to be met, and that is that for each of these x values, there is only one corresponding y value. And for the makeup of what we have for these functions, we have in the case of the domain of this function. Now the domain is in reference to the set of x values, and in this case we have -1, 2, and 3. Again, so we have for the domain, you're looking at your x values, and for that which would define the set of y values, we have the range. So again, the range is in reference to y values. And for this set of ordered pairs, we have for the range, we have 4, 9, and 17. Now in the second example, we have another case of a function, and so we have 1, 2, -3, -4, as well as 5 and 6, along with -7 and -8. Now, in the case of the domain, again, this could be expressed in varieties of ways, but it's going to be the set of x values. And if I put these together in the order that I see them, and from left to right, so I have 1, -3, 5, as well as -7. I could also arrange these values in any fashion. Say if I put in order from smallest to largest, I would have -7, -3, 1, and 5. As for the range, again, we have with a set of y values, so I have 2, -4, 6, as well as -8. If I were to rewrite, so I have -8, -4, 2, and 6. And again, for each x value, there is only one corresponding y value. Now, in terms of the litmus test, whether we're going to have these items, these sets of ordered pairs, to be functions or not. Now, we have, say for the first grouping, have 1, 2, 4, 5, 3, 7, and 4, 5. So 1 is uniquely paired up with 2. Again, I have 4 paired up with 5, 3 paired up with 7. Now 4 reappears, but it is still only paired up with 5. So you might have the repetition of an x value, but if it's still the same unique y value upon which it is paired up with, we still have a function. Now for the second case, you have 1 paired up with 2. 2 is paired up only with 2. 3 is paired up only with 2. Likewise, you have 4 only paired up with 2. So now you have the repetition of the y value at 2, but since each of the x values is paired up only with one corresponding number, we still have a function. Now if I switch up the order of the coordinates, you have 2 paired up with 1, you got 2 paired up with 2, and right away, in terms of how the arrangement is made out, notice we have with 2 repeating and with different y values. Guess what? So we have out of these, you have same x value, but different y terms. Okay, so this is not a function. And in the case of the last set of order pairs listed, we have 1, 2, 4, 5, 3, 7, and we have 4, -5. Now, for the easy part, 1 is paired up only with 2, 3 is paired up only with 7, whereas in the case of the x value of 4, okay, that is paired up with 5 in the first case, -5 in the second, and so we have between these 2 points, you got same x, different y, and because of that, okay, this set of order pairs does not qualify as a function. Now, in what we have regarding functions, if you are not given a set of order pairs but instead are given graphs, we have in graphing a function will satisfy the vertical line test, and the vertical line test states that at any x value, a vertical line cannot intersect the graph at more than 1 point. And in terms of what will constitute a function on the basis of looking at graphs, and we'll say that in the first case, all right, if you have a vertical parabola, and we'll say we have y is equal to x squared minus 4, in terms of whether this is going to be a function or not. So if I run a vertical line through this, if you notice, okay, we have intersection at most 1 point. So just kind of moving throughout. Okay, if you notice, you have at each x value, you have intersection at most 1 point. And so for this particular graph, okay, this is going to define what we have for a function. Okay. Now let's say that for what we have in the case of y is equal to 4x minus 3. All right. If you test this out, okay, so if you run a vertical line through this, okay, and so we're going to have, again, intersection at most 1 point. So for y is equal to 4x plus 3, okay, that is going to be a function. In the next graph, okay, we have a circle, okay, and we have centered at the origin, and the radius is going to be 2. And the equation for this particular circle is going to be x squared plus y squared is equal to 4. And if you notice, okay, we have from the start, okay, we have, if you exclude what we have with the endpoints at -2 and +2, notice we have for all other values of x in between, okay, we have intersection between the vertical line and the circle at 2 points. And so since we have intersection at more than 1 point, now a circle is not going to be a function. Again, it does not satisfy the condition that for each x value throughout, there will be only one y value, and so a full circle does not fit the bill. However, if I were to take the upper half of the circle and have the formation of a semicircle, and we're going to have here, if you notice from end to end, we have intersection at most 1 point. So while a full circle is not a function, we have, say, the upper half of a circle or even the lower half of a circle will constitute a function. So a semicircle is going to be a function. And in the case of a horizontal parabola, so you have x is equal to y squared minus 4. And in this one, you can see this already. Okay, if you run a vertical line through this, you have, say, at x is equal to 4. You have 2 points of intersection. Again, so you have violating the rule that you cannot have an intersection between the graph and a vertical line at more than 1 point. So for a horizontal parabola, okay, that one is not a function. Now for what we have in reference to functional notation, okay, we have in place of y, you might see the expression f of x or g of x. And f of x, this is just a functional notation for what we otherwise say is going to be y. Now for f of x, now any term that is in the parentheses is going to be regarded as the input. And for f of x, x is referred to as the input variable or the independent variable. And for what we have in the case of y, y is referred to as the output or dependent variable. Now, if we have like for defining function values and expressions, okay, we have in the case of f of x is equal to 2x plus 5. If we were to determine f of negative 8, f of 5, and f of x plus 2, and say we have with the linear function, okay, so you have for y is equal to f of x, you have f of the input is equal to 2 times the input plus 5. And if I have x at negative 8, so I have f of the input, you have 2 times the input plus 5. So here we have 2 times negative 8 is negative 16 plus 5, which will come out to negative 11. For f of 5, I have 2 times 5, which is 10, plus 5 is 15. And for f of x plus 2, I have 2 times the quantity of x plus 2. So the input is x plus 2. 2 times the input becomes 2x plus 4. Adding 5 to this, so we have 2x plus 4 plus 5, and so we have 2x plus 9. Now for the quadratic function or second order function, we have f of x is equal to x squared plus 2x plus 3. And if I were to determine, say, all of f of 5, f of negative 2, and f of x minus 3. So again, we have in the first layout, if you notice, you have f of x is equal to x squared plus 2x plus 3. For the input setting x to 5, x squared becomes 5 squared, 2 times x becomes 2 times 5, and then we have plus 3. And following through, 5 squared is 25, 2 times 5 is 10, plus 3. Adding all together, we have 38. Now with the input at negative 2, again, if you use a calculator, do not forget to use parentheses for negative values. And so we have negative 2 squared, which will be 4. Now for 2 times x, we have 2 times negative 2, so we have negative 4. And if you notice, we have 4 minus 4 will cancel, but you had the cancellation to be overridden by the plus 3 at the end, so we have the final value in this case would come out to 3. Now for the variable expression, x minus 3. Okay, so we have f of x minus 3. So x squared is going to be the square of x minus 3. 2 times x becomes 2 times the quantity of x minus 3, and then we have the plus 3. And in terms of establishing things, again, for the square of x minus 3, this means x minus 3 times itself, so we have x squared minus 6x plus 9. So we'll just put this trinomial at the front. 2 times the quantity of x minus 3 is going to yield 2x minus 6. And then we have the plus 3 to tag along. And in terms of combining our expressions, okay, we have x squared is the only term in the midst. And we have in the first degree, we have negative 6x plus 2x, which will be negative 4x. And then we have, for the constants, we have 9 minus 6 is 3, adding 3. So we have for this final output, okay, we come out to x squared minus 4x plus 6.